Here's your Chapter 6 study guide. For question 1, given the relation described, identify the input and the output. For number 1, Trevor wants to find the total value of dimes that he has in his piggy bank. So the input would be the cost of 1 dime. Once Trevor knows the value of 1 dime, his output would be the total value of the dimes in his piggy bank. For number 2, Mrs. Thompson wants to calculate the total cost of 10 gallons of gasoline. Her input would be the price or the cost of 1 gallon of gasoline. Then, since she's trying to figure out the total cost, that would be the output, the total cost of 10 gallons of gasoline. For number 3, we're to look at the mapping diagram and state the type of relation. Tell whether the relation is a function and explain. So if we look at the mapping diagram, I can see that the number 3 has 2 outputs. So this would be a one-to-many relation. Therefore, since the 3 has 2 outputs, this is not a function. So our explanation could be something that states that since the number 3 has 2 outputs, it is not a function. To be a function, every input has to have exactly 1 output. So I typed up this response. To be a function, every input must have exactly 1 output. 3 is partnered with 1 and 7. So 3 has 2 outputs. This means the mapping diagram is not a function. We could also do a quick graph, a sketch of this to see what it looks like. So I made a quick little sketch of a graph just to show you. It's not the best thing, but okay, so 2 pairs with 7. So over 2, up 7, put a point. 3 pairs with 1. And 3 also pairs with 7. And 8 pairs with 11. So that would be like somewhere up here. So now you can see, if you did the vertical line test, you could see that 3 has 2 values. So the input of 3 has 2 outputs. So it does not pass the vertical line test. So it's not a function. Number 4, tell whether the relation represented by the graph is a function and explain. So I'm looking at the graph and I notice that it is a curved line. So when given a graph, I like to do what's called the vertical line test to make sure every input has exactly 1 output. So I'm going to drop a line, and I can see that that line only hits 1 place. But then I'm going to move the line, and as I move the line, I can see that the graph only hits 1 place. Okay, so here I'm looking right there, you see it hits 1 place, and then I move it, and you can see that right here it hits 1 place, and then I'm going to move it, again it hits in 1 place, right there, and then I'm going to move it again. And then you can see it. Just every input only has 1 output. And then finally, whoops. There, it hits 1 place. So it does pass the vertical line test. So this is a function. And then my explanation. So I put every input has 1 output. This graph also passes the vertical line test. tell whether each function is linear or nonlinear, then tell whether the function is increasing or decreasing. Okay, we learned that linear functions take the format of y equals mx plus b. So I'm looking here, v equals e to the third power. Right there, because that's to the third power, that's going to make this nonlinear. If you had no power, like in y equals mx plus b, then it would be linear. So our first answer is nonlinear. So the next part is it increasing or decreasing? So we're looking for the volume of a cube as a function of its edge. So if we take the edge to the third power, then we will get the volume. So I would think that that means this is increasing. Okay, the same directions for number 6. We're telling if it's linear or nonlinear, and then is this increasing or decreasing? So our first step to determine if it's linear or nonlinear is to look to see if it is consistent in the x's and in the y's. So in the x's, it looks like it's increasing plus 1 every time. So the x values, or the input, are consistent. And then the y values, now to go from -1 to -2, you're going to decrease 1. And it looks like this is consistent. It's decreasing 1 each time. So that means that this function is linear. And then, since every input has an output that is decreasing by 1, then we will say this whole function, this linear function, is decreasing.